All right, so in this video, we're gonna divide polynomials using synthetic division as opposed to long division. Now, synthetic division, there's sort of a catch to it. It's way faster than long division, but it's not gonna divide every polynomial. It's only gonna divide polynomials by binomials or with polynomials with basically, what I'm trying to say is that there has to be just a plain x in the binomial you're dividing it by. It's not going to divide things like 3x plus 2 or, 6x plus 2 or negative x plus 2. It has to be a plain x here. And it doesn't really matter what this is. It could be positive, negative. That could be any number it wants to, but it has to be a plain x here for you to use synthetic division. Now, there are some workarounds that you can do to divide polynomials that don't have a plain x, but when we get to those, I'll explain how to do that. But for now, just make a note that you can only use synthetic division if you're dividing by a binomial that's just got a plain x on it. You're not dividing by a 2x plus 3 or any type of x plus 3. Just a plain x would work, okay? So let's talk about how to set it up. Setting up is very interesting. It's not difficult, but it's interesting. So to set it up, I put a little box over here in the top left, and in this box is going to go my a value. Now you're probably wondering, what a value are you referring to? And I'm referring to this number here. This number is sort of my a value. However, the a value is sort of the opposite of that number. So even though it says plus 2, the a value is actually a negative 2, okay? Because technically, we're dividing by x minus a. And so if we're dividing by a plus 2, that means we're dividing by a negative 2, because that's minus negative makes that plus show up. But long story short, just remember that whatever this number is here, you have to change its sign, and that is your a value. And that's the number that's going to go in this box over here, okay? So if it was x plus 4 that I was dividing by, then negative 4 would be my a value. If it was x minus 7, then it'd be a positive 7 I would use as my a value. So just change the sign. Now, out next to it, we're going to write the coefficients of the polynomial we're dividing from. So in that case, and it's got to be in standard form, and we have to put zeros in for any terms that we're skipping or that are missed in this problem. So notice, for example, we have a 3x to the fourth, a negative 1x to the third. We have no x squared term, right? So a 0x squared. Then we have a 5x and then minus 1. So we're just going to list the coefficients of these out. So starting from biggest degree to smallest, so first is 3, then negative 1 for negative 1x to the third, and then a 0 for the 0x squared term, and then a 5, and then a negative 1. So we're just listing out all those coefficients, but you have to remember that if there's any term that's missing, for example, obviously the x squared term in this case, we have to put a 0 in for that missing term, okay? Otherwise, the problem's not going to work. So remember to fill that void if there is one. So that is just how you set it up. Now also, I would leave a little bit of space below those numbers, just enough to write another number and draw a line. All right, so let's get started. Now, everything we're going to do is sort of just a quick repeated pattern. So the first thing, my first term, my first coefficient, 3, I'm just going to bring that down. No matter what that number is, you always just bring it down. Don't ever change it. Don't do nothing with it. Just bring that down and put it below that line. Now, what's going to go under this line, this is where my answer is going to be. Everything that's going underneath this line, that's going to be part of my answer. So 3, bring it down. It's all good. Any number that goes below that line, for example, this 3, I'm going to multiply it with my a value. So I'm going to do 3 times negative 2. 3 times negative 2 is negative 6. I'm going to put the negative 6 underneath the next term. All right. Now I'm going to add these two terms up that are here. Negative 1 minus 6. It's not a trick. We don't have to think about the sign at all. It's just Since it's -1 and a -6, we're just going to combine them. -1, -6 makes a -7. And that's going to be the new number, the next term below the line. Like I said before, any number that goes below this line, we're going to multiply it with a. So now I'm going to do -7 times -2, which makes 14. So I'm going to put 14 under that next term and then add those terms together. So 0 plus 14 is 14. All right, now again, any number that goes below the line is getting multiplied to that a value. So now it's 14's turn. 14 times -2 is -28. And that product's going to go under my 5. So now add them up, 5 and -28. Well, 5 minus 28 is -23. And again, anything that goes below this line gets multiplied to a. So -23 times -2 is +69. So then add those. -1 plus 69 is just 68. So now you're wondering what all these terms are down here. This is my answer, but now we have to put all the x's back in it. So I always do this the same way every time. But this far right term is always the remainder. Okay, that's my remainder. Now working my way up from there, next to my remainder would be my constant term. And then it's all in standard form. So if that's my constant term, then the next one would be the x term. The following would be the x squared term, and then followed by the x to the third term. So I always start from right and then work my way left, and it always goes ascending in this order. Remainder, then constant, then x squared, then x to the third. So my answer here, we have 3x to the third minus 7x squared plus 14x minus 23, and then plus the remainder is 68. So remember, we write the remainder as 68 over whatever my divisor was, so x plus 2 in this case. And that's the answer. Now to do that with long division would probably take about 5 times as long, 10 times as long, depending on how slow you work. But that's it. So it saves a lot of space. It's very simple and very repetitive because you just do, multiplying, then adding, then multiplying, then adding, then multiplying, then adding. It just kind of repeats over and over again. Just be careful on, make sure you remember how to write your terms out. So remember, it's always going to start with the remainder on the right, and then you just work your way up into standard form. So that explains how all those numbers we get turn into the terms in our answer. All right. Let's try another. So let's show you all the beautiful work that we did. Wait, 46. Oh, okay. I'm thinking of another problem. I don't know. I guess I wasn't doing the math. I just thought I would look through this PowerPoint ahead of time. It was 45, not 69. 69 is probably in the next problem. I wasn't really thinking very clearly. All right, let's just go ahead and do this problem. So I apologize for that mistake. Lulz. All right, so the a value, number that's going to go in this box here. So my a value comes from this. Remember, it's not actually that. It's the opposite of that. So since that says x plus 3, I know the a value is -3. So that's the number we're going to be multiplying by a lot. Now next to it, we're going to put the coefficients of my polynomial. Remember to write 0 for any terms that are being skipped. Now I'm not skipping any terms here because I have an x squared, then an x term, and then the constant. So I'm not jumping any terms. I'm just going to write the coefficients, 6, -5, and -6. By the way, I'm just going to leave that mistake in there because I don't feel like making another video. I'm tired, man. All right, let's just get the problem. So I've set it up. First step, I always bring, go away. I'm going to bring the first term down every time. That's never going to change. So just bring that 6 down. All right, now let's multiply. 6 times -3, it's going to be -18. So we're going to put that -18 there, and then we're going to add those terms. -5 minus 18 is -23. Hopefully I don't make any mistakes on this one. Yeah, and then this is the number I was thinking of. So again, I wasn't thinking of the multiplying. I was just thinking of the problem. And this is the problem I was thinking of. So -23 times -3 is a +69. I'm not wrong this time. That is correct. And then -6 plus 69 is 63. So that's my final answer. So remember, this far number on the right is my remainder. And then work your way up or I guess to the left, the next would be the constant and then the x term. So again, if there is more terms here, then the next one would be the x squared and then the x to the third, but obviously I don't have those terms, I just have these. So my answer is 6x minus 23, and then plus the remainder, which is 63 over x plus 3. Because remember, the remainder always goes over that divisor. There's your answer. And just to check my work, hopefully I didn't do any of the multiplication wrong. Yeah, so there you go. So again, I was thinking of one problem ahead because I had looked over this beforehand and I just try to memorize the numbers, I guess. All right, let's do one more. So it's pretty, simple, really. So my a value here, notice I've got minus 6. So my a value is really a positive 6. The coefficients are going to be 1 for 1x squared, negative 3 for negative 3x, and then minus 18 for minus 18. I'm not skipping any x terms because it goes straight from x squared to x to my constant, so nothing's being skipped, so I don't have to fill in any zeros. And now let's start. Bring down the first term, as always. So bring down the 1, and then multiply that with the a value. 1 times 6 is 6. And then add those terms. Negative 3 plus 6 is positive 3. And then multiply 3 with 6. It's going to be 18. And negative 18 plus 18 is 0. So remember, this is my remainder, followed by my constant, and then my x term. So this is just 1x plus 3, and then with no remainder, so we don't have to write the remainder. We just have x plus 3. Simple as that. So that is dividing polynomials by synthetic division. Now, synthetic division is a very important method because we're going to talk about, I think in the next video, other uses for it. But I'll let that marinate for now. All right, that's it. I'll see you in the next one. Bye.